All right, in this video, we're going to look at the idea of doubling time, what's called a doubling time, okay, meaning the amount of time that it takes for a population to double. So when something doubles, let's say that it's going from 50 up to 100, okay, or something is going from something's going from 400 up to 800, okay? And so doubling means multiplying by 2. So 50 times 2 is 100. 400 times 2 is 800. And so that's what doubling means, okay? And it's an important idea in exponential growth. So sometimes you'll be asked, well, what is the doubling time of an exponential function? How much time, t, does it take for the population to double, okay? How does it, if the population is 400, how long does it take before it's 800, okay? And all you have to do is set p sub 0 to 1, and then set the ending value, p sub 2 to 2, and then just solve for t. Now to solve for t, we're going to need a logarithm, and so, but we already know how to do that from lesson 22, so let's go ahead and do that. So it says, what is the doubling time of something that grows by 8% per year? This must be a discrete formula because it doesn't say continuous. So we're going to use p sub 0 times 1 plus 8%. 8 divided by 100 is 0.08. So 0.08 to the power of t is equal to p sub t, okay? And so now this is going to become 1. We're going to make p sub 0 1. Okay, so 1 times 1.08 to the power of t is equal to 2. Okay, now I want you to notice that we don't actually have to put this 1 here, because remember, when we multiply something by 1, it's just whatever it is. So really all we need is just this. 1.08 to the t power is equal to 2. And now it's in the correct form for us to solve an exponential equation. We can solve for t. We're going to do log base 1.08 of 1.08. And so it's going to be log base 1.08, this is from lesson 22, of 1.08 to the t power, okay, is equal to log base 1.08 of 2. Now over here, we can cancel out the log base 1.08, and we bring down, and we have t is equal to log base 1.08 of 2, which we can put into a calculator. Okay, so let's go ahead and put this into a calculator. And let me remind you that this is going to be the same thing as the natural log of 2 divided by the natural log of 1.08. That's our change of base formula. Okay, and so we're going to do the natural log of 2 divided by the natural log of 1.08, and then press enter, and our answer is 9.006, okay? And so the answer is 9.006. Now you may just say that it's 9, but for now we're going to say, for instruction purposes, we're going to say round to 3 digits. So the doubling time, the amount of time that it takes for something to double, if it grows by 8% per year, is 9.006. And that could be years, it could be minutes, it could be hours, it could be weeks or months, okay? Now let's find out the doubling time of something that grows continuously. We're going to do the exact same thing. We're going to set p0 equal to 1 and p sub t equal to 2. And so we know the formula is p sub 0 e to the power of rt is equal to p sub t. So we're going to put a 1 in for p sub 0. 1 times e, the rate is 8%, so that's 0.08 t, okay, equals, and we're going to put a 2 in for p sub t. Now, because 1 times anything is this is this, whatever it is, we're going to get rid of the 1. So really we just need e to the power of 0.08t times 2. And we're going to use a natural log to solve this, just like we did in lesson 22. We're going to do the natural log of this side and the natural log of this side. So we wind up with the natural log of e to the power of 0.08t is equal to the natural log of 2. And now we're going to cancel out e and the natural log, and we're going to have 0.08t equals the natural log of 2. Now we're going to divide by 0.08 on both sides. 0.08, that's a little ugly, 0.08. We're going to cancel the 0.08, and now we have t equals, so we have t, that's an ugly t, t equal, that's no better. T equals the natural log of 2 over 0.08, which we can now plug into a calculator, okay? So we'll do the natural log of 2 divided by 0.08, and we get 8.664. So t is 8.664, and that means that the time, the doubling time, the time in this continuous function for a number to double is 8.664, okay? Now we're going to look at what's called half-life. It's the opposite of doubling time. It's not the amount of time to double a number, it's the time it takes for a number to get cut in half. Okay, the time that it takes to cut a number in half is often called the half-life of the exponential function, okay? Or you could call it the half time, but it's mostly referred to as half-life, okay? So here we're saying, well, how long, what is the amount of time that it takes for 50 to become 25, or for 400 to become 200? How long, how much time does it take in this exponential function for the starting value to become half? How long does it take for the ending value to be half of the starting value? Well, since it's half, since the ending value is half of the starting value, that's smaller. And therefore, it's going to be an exponential decay function, okay? And so, to find the half-life, all you do is set p sub 0 equal to 1, and set p sub t equal to 1/2 or 0.5 if you want to, okay? And then solve for time, just like we did in the last one. So this is saying, what's the half-life of something shrinking by 3.28% per day? Okay, so our time now is days, okay? And so our formula, it's going to be p sub 0 times 1 minus r to the power of t is equal to p sub t. We're going to replace p sub 0 with 1, and then we're going to do 1, in this case r, well, what is r going to be? Well, we're going to take our 3.28%, 3.28, we're going to divide it by 100, put it in a calculator, and that's going to be 0.0328. Okay, and so over here, we're going to put p sub 0 times 1 minus 0.0328 to the t power is equal to p sub t. And so we're going to plug in 1 for p sub 0, and then we're going to do 1 minus 0.0328 in the calculator. 1 minus 0.0328 is going to give us 0.9672. So in here we're going to put 0.9672 to the power of t is equal to, and then we're going to put up here 1/2 or 0.5 in for p for the ending value. So let's put 0.5, okay? And because we have 1 times, we can get rid of that, okay? So now we're going to solve this with a logarithm, okay? So we're going to do log, oops, excuse me, use lowercase, log base 0.9672 of 0.9672 to the t power is equal to log base 0.9672 of 0.5. Go. Now the log base 0.672 of 9.9672, that's going to cancel, and all we have left is t. So now we have t is equal to log base 0.9672 of 0.5. And now we're going to do a change of base. We're going to do the natural log of 0.5 divided by the natural log of 0.9672, and we're going to key that into a calculator. So we're going to do natural log of 0.5, close parenthesis, divided by natural log of 0.9672. And then press execute, and we get 20.784. 20.784. And it's days. So it takes 20.784 days in this exponential function for the starting value to get cut in half. And so the half-life of this function is 20.784 days. Now let's do one with a continuous function. What is the half-life of something shrinking continuously at the same 3.28% per day? So again, we're going to start with p sub 0, but this time we're going to put an e, and we're going to change 3.28 into 0.0328, and then we'll put a t on it, equals p sub t. But remember, because this is shrinking, we have to put a negative on the 0.0328, okay? And so now we're going to put a 1 in for p sub 0, so we'll have 1 times e to the power of negative 0.0328 times t is equal to, and we'll put a 0.5 in for p sub t. And again, we don't need the 1 because 1 times this is just equal to this. And so now we're going to solve this by applying a natural logarithm because the base is e. So we'll apply a natural logarithm to this and to this. So I'm going to come over here and we'll do the natural log of e to the power of negative 0.0328 t is equal to the natural log of 0.5. Then we will cancel the natural log and the e, and we will have just negative 0.0328 t is equal to the natural log of 0.5. Now we will divide both sides by negative 0.0328 divided by negative 0.0328. Over on the left, it'll cancel. And we now have t is equal to the natural log of 0.5 over negative 0.0328. And now we're going to go ahead and put that in the calculator. Okay, so we'll do natural log of 0.5 divided by negative 0.0328, and we get 21.133. So this 5 will round this 2 up to a 3. So 21.133, and that is in, again, it's days, okay? So t is, the half-life is, let's see, 21.133, 21.133 days. Okay, and that is the half-life of this continuous decay function.